Dopo la coordinatrice del progetto lo dirà in inglese, però almeno After in English, before to only for the SMEs, okay? And after, when we start with the video, Giuliana will introduce the BIOMAT Project, ok? Allora, il progetto, diciamo, il workshop si inserisce all'interno di un progetto europeo di 26 partner. Ogni partner ha sviluppato qualcosa nell'ambito delle schiume poliuretaniche composite. Quindi all'interno del progetto c'è chi ha sviluppato i filler, chi ha sviluppato i precursori poliuretanici, chi ha fatto le formulazioni e chi in qualche modo ha messo su un impianto pilota per processarle. In tutti i settori dove vengono utilizzate le schiume poliuretaniche, quindi settore edile, construction, settore automotive, si sviluppa la schiuma poliuretanica per fare il volante, settore arredamento, quindi parliamo di sofà, parliamo di materassi e basta, diciamo, questi sono, diciamo, i settori in cui queste schiume vengono utilizzate. Qual è lo scopo? Lo scopo è essenzialmente che voi in qualche modo possiate presentarvi, perché ovviamente, diciamo, almeno avere l'idea di quali sono le tipologie di aziende che oggi sono qui presenti, ma soprattutto possiate voi avere l'opportunità di vedere qual è il know-how che è stato sviluppato all'interno di questo progetto. Questi know-how in qualche modo sono disponibili, cioè nel senso che l'azienda può avere accesso a questo know-how attraverso una forma, io definisco un po' particolare, cioè ci sarà a dicembre un open tender, una gara, all'interno che non è una vera e propria gara, cioè nel senso che l'azienda può iscriversi su un sito, che è il nostro sito, diciamo, del progetto, e accedere alla possibilità di sfruttare il know-how. In che modo? Immaginiamo che un'azienda possa essere interessata all'uso di una schiuma flessibile, ne vuole conoscere le proprietà, vuole sapere per esempio la formulazione ed il processo di produzione e avere informazioni sull'impianto pilota. Accedendo su questa piattaforma a questa gara, decide di voler andare a conoscere questo know-how ed è totalmente gratuito. Ovviamente ogni partner ha sviluppato qualcosa, non tutti i partner ovviamente sono italiani, ma fanno parte di una serie di paesi sparsi, diciamo, in tutta Europa, quindi laddove c'è l'interesse della schiuma che è stata sviluppata da un'azienda che sta in Germania, si va in Germania a carico, diciamo, dell'azienda, e l'azienda mette a disposizione il know-how, le competenze, l'impianto e anche ovviamente ricercatori per mostrare, diciamo, tutto il processo produttivo. Quindi questo è in sintesi quello che in qualche modo oggi sarà trasferito a voi da parte nostra. Va bene? Ok. I don't know, now we can start? Perfect. With the SMEs? Yes. Okay. Now we can start with the workshop. In the first part of the project of the workshop, each company could introduce our company, their company, and by using a presentation or by introduction themselves by sit. Okay, the first presentation, Steve Rite. Okay.
Allora,
no, one moment. Before to start with the presentation of the SMEs, I want to introduce the coordinator of the project, sorry, Juliana. The group that is been coordinate the project is Senti from Portugal, and the referent person and the scientific responsible of this project is Juliana Oliveira.
Hi everyone, good morning. Thank you all for your presence here today. This is our first workshop, the first of 3, so we hope that it goes as well as possible. I also extend my my acknowledgement and my thank you to all of the companies that agreed to be here with us today. You are very important to make sure that our testbed and our project is as successful as we hope it can be. So the first part of the agenda will of course be the introduction of the companies that are here supporting us today, followed by a small introduction to the project which I'll be providing, and then the detailed description of all of the services that we'll have available in our future Open Innovation Testbed. So I'll pass the word on to Tiferite. Is it working?
Buongiorno a tutti, rappresento l'azienda Stiferite, sono Fabio Raggiotto, il responsabile tecnico. Stiferite è un'azienda che esiste dagli anni 60, da quando il nostro fondatore scelse il poliuretano per isolare dei frigoriferi, in quanto si accorse che aveva eccellenti caratteristiche di isolamento termico e queste erano mantenute anche in condizioni umide tipiche dei frigoriferi, dei congelatori degli anni 60. E nel 1968 installa uno dei primi impianti in continuo per la sintesi di pannelli isolanti in poliuretano espanso rigido a Padova, e d'oggi in questo stabilimento sono presenti 2 impianti in continuo. Siamo in grado di produrre milioni di metri quadrati l'anno di pannelli isolanti in poliuretano. Diede al nome al prodotto Stiferite da Stivamiglio Ferdinando Isolanti Termici, quindi rappresentiamo un'azienda italiana e siamo un produttore italiano. I nostri pannelli vengono realizzati in un impianto simile a quello che vedete qui schematizzato. In pratica misceliamo una serie di materie prime per produrre schiuma poliuretanica di tipo PIR su un rivestimento inferiore che fa da vettore, serve cioè a trasportare il liquido all'interno di un impianto di laminazione, uno stampo continuo, dove in una manciata di qualche decina di secondo il liquido diventerà una schiuma rigida e solida. Prima di incontrare la faccia superiore del nastro, il liquido incontra il rivestimento superiore, quindi tutti i nostri prodotti hanno 2 facer sulle 2 facce principali che conferiscono al materiale delle caratteristiche e delle peculiarità. L'azienda che rappresento ha tutta una serie di certificazioni aziendali, dall'ISO 45000 all'ISO 9000, 14000, marcature di prodotto. I nostri pannelli per il settore delle costruzioni hanno il marchio CE obbligatorio secondo la UNIN ISO 13165 e per il mercato dell'industria secondo la UNIN ISO 14308. Disponiamo poi di alcuni sistemi costruttivi che hanno una marcatura CE volontaria sulla base di uno European Technical Assessment. Abbiamo tutta una serie di marchi legati alla dimostrare la sostenibilità di questi prodotti, ovvero le dichiarazioni ambientali di prodotto EPD, dei marchi specifici sul contenuto di riciclato come Remade in Italy o delle certificazioni specifiche sul contenuto di composti organici volatili. Disponiamo poi di tutta una serie di documentazioni che servono a orientare le scelte nel mondo delle costruzioni sulla base delle nostre tipologie di lastre. Tipologie di lastre che sono tantissime. Oltre alle diversità legate al contenuto di poliuretano presenti nei vari prodotti, questi ultimi si differiscono sostanzialmente per il tipo di rivestimento. Abbiamo un portafoglio prodotti estremamente ampio e ciascuno di questi prodotti di fatto è sviluppato per uno specifico impiego. Il nostro know-how è che siamo degli autoformulatori di schiuma poliuretanica da circa 25 anni e così siamo in grado di sviluppare da noi stessi i prodotti e le specifiche che hanno. I pannelli che noi realizziamo hanno eccellenti performance di isolamento termico perché di fatto a parità di performance energetica hanno dei valori di conducibilità molto bassi e quindi possono essere utilizzati in spessori molto ridotti, hanno una certa inerzia termica per cui sono utilizzabili da meno 40 a più 110 gradi centigradi, hanno eccellenti performance fisico-meccaniche sia sotto carichi statici che dinamici, sono stabili alle condizioni normali di esercizio tipiche del mondo delle costruzioni in fase di costruzione e in fase di utilizzo dell'edificio, sono impermeabili all'acqua, hanno assorbimenti trascurabili e, come dimostrato da tutta una serie di studi che abbiamo fatto in collaborazione con università piuttosto che enti di certificazione internazionali, hanno caratteristiche che si mantengono nel tempo, che questa è una prerogativa per noi fondamentale. Hanno un buon comportamento di reazione al fuoco, questo è per noi un elemento fondamentale, in quanto sempre più nel mondo delle costruzioni c'è attenzione sulla sicurezza degli edifici, in particolare essendo delle schiume di tipo PIR, carbonizzano al contatto con la fiamma diretta o alle alte temperature e questo permette di ottenere dei prodotti che sono, diciamo, sicuri nell'impiego e nell'esercizio, sono innocui e sono facilmente lavorabili. Dove vengono utilizzati? Nel settore delle costruzioni principalmente e soprattutto nelle diverse soluzioni applicative. Non abbiamo delle lastre universali. La importante gamma di prodotti che noi realizziamo è finalizzata perché ciascun pannello abbia uno specifico impiego per specifiche applicazioni. Così abbiamo soluzioni conformi per qualunque tipologia di copertura. Siamo stati la prima azienda in Europa a sviluppare dei pannelli per l'applicazione a cappotto in poliuretano espanso rigido. Abbiamo soluzioni conformi per applicazioni in orizzontale a pavimento, sotto carichi anche importanti come ad esempio nel caso delle celle frigo. Abbiamo soluzioni per applicazioni industriali nel settore dell'automotive e soluzioni per le condutture dell'aria ventilata. Io spero di essere stato chiaro, qui avete i miei riferimenti. D'accordo.
So next on our agenda. Sorry. So next in our agenda is the company Glass to Power. So I would kindly ask. Thank you.
So hi to everybody. I'm sorry for my English because it's a lot of time I don't speak, so be kind to me, please. My name is Marina Gemmi. I work in Glass to Power, that's a startup now, a very little company, an Italian company. And we are very glad to be here because we think that linking innovation is necessary, especially in the building industry. A very short story about us. We started in 2014, and in 5 years, we put an academic scientific research into the market, and now we can sell our product. Our product is a product inside a collective imagination versus the reality. I think that everybody knows here the situation about the climate exchanges and which is the target that Europe fixed. And I think that this picture explains itself how many surfaces are available to put inside or in the envelope, something that is able to insulate the external environment and the internal, and so saving money and saving energy. Our company works in the BIPV market. It means that we produce an IGU, an insulated glass unit that's in the envelope, can see through product energy, giving a good inside light. And first of all, an important situation is regarding the BIPV industry. Those are the target, the projection, but there is really a lot of job to do. And I think that BIOMAT and Glass2Power can have common goals because our missions and our visions are really near. When BIPV meets the building, there is a real constraint regarding the aesthetic aspect of the glass and the transparency that it's needed inside. This is our solution. We produce nanoparticles, nanocomposite, that we put inside a slab. This slab makes a sort of trick of the nature, and we have a guide of the light on the edge of our slab. And on the edge of this slab, there are the PV cells that make the conversion through the energy. So we don't have the PV cells on the window surface, but only on the perimeter. And this is the result. You can see through and you can produce energy thanks to the PV cells on the perimeter. I leave you read it. You don't need my explanation. Those are the certifications we are compelled to be in line with. And this is a great problem regarding PV, regarding buildings, and regarding all the kind of certification, because we met the glass certification, the PV certification, the fire certification, and the CE certification, and the declaration of product regarding the CPR 305, that's a regulation for building products in Europe. So that's we are, and thanks to be here.
Thank you. Thank you so much. Now going on to Isopan.
No,
No, the last one.
the last. Isopan. I think so. This. And this one to go. Okay. So, good morning, everyone. My name is Bruno Nigro. I'm a physical chemist, and together with my colleague Soledad Zanetti here in the audience, I work in Isopan, manufacturer of sandwich panel. But first and foremost, let me thank you, the host, the Institute of Polymers and Composites. Particularly, let me thank you, Dr. Letizia Verdalotti, for having invited us, and clearly the BIOMAT European Research Project. Very light, fast presentation, because at the end of the day, we are all here to listen what you people are going to show us, I think. So let's go straight on to the presentation. Before introducing Isopan, I have to just introduce Mani Group, which is the mother company of Isopan. Mani Group is involved in the drying construction business from many points of view. It's located, the headquarters is located in Verona, Italy, and we have manufacturing sites in Europe and overseas. These are some figures of the company. We are 1,200, roughly. 14 operating companies, manufacturing sites. And a part of the financial figures that I'm not confident of the meaning of them, sorry, but I would like to point out that we move a substantial amount of raw materials and, of course, final products. So the business of Money Group is basically divided into 5 sister companies. The historical one is Money Cipre, over 60 years of history. It's specialized in prefabricated steel, such as slabs, bars, pipes for the building industry, basically, and beams, of course. Basically providing the skeleton of a modern building. Money Inox, which is specialized in processing stainless steel and also in surface treatment of it. And its main end users are the manufacturer of ovens for the food industry, pipelines for chemical plants, tank for fluids of various kind. Here we are. As Isopan, we provide insulation of buildings via roofs and walls. We will get into that in a moment with a little bit more detail. Money Energy, taking care of the energy management, I think it's called operation and management of the building, energy management, carbon management, solar plants, IoT, Internet of Things, and all this kind of thing. And last but not the least, Money Green Tech. Money Green Tech is basically make the synthesis of the 4 sister companies, providing an integrated solution for the building industry, and very nice stuff that I invite you to have a look later in our website. Is call them prefabricated modules is really an understatement, believe me. So just for those of you who doesn't know what a sandwich panel is, I would like to thank you also our competitor for the very detailed presentation. I haven't brought detailed information here. So a sandwich panel is basically two metal sheets jointed together via an insulating core, rigid. Usually it might be a polymer foam, always polyurethane at the end of the day, or well, always polyurethane, and or mineral wool. And of course, there are various shapes, sizes, and also the rule that the 2 surfaces are planar, as you can see, is easily broken. And the joint is also very important. There are a plurality of ways to attach one panel to the other in order to prepare a flat surface or a flat roof, of course. We have manufacturing plants in 6 countries. 6 are in Europe, and 1 is overseas in Mexico. Again, some figures. Probably most interesting is the quantity of panels per year that we, as a group, we sell, and we move, as you can see, a substantial amount of chemicals, which of course are ingredients for polymer synthesis of the foam. Of course, the sandwich panel is ubiquitous and very simple in the earth, but at the end of the day, it's diversified for very different end users. And so our colleagues, the architects, are doing a terrific job trying to satisfy any kind of end users, from heavy users like refrigerated cells and farms, stables of farms, up to ventilated facade and green roofs for commercial residential buildings. Okay, clearly as a research and development guys, we are entitled to think a little bit outside the box. Maybe it's also the reason why we are here, right? But since the number of the company are quite big, it's also mandatory to work to incremental innovation, right? So we can try to put one foot in a place and another in the other. And okay, our 4 drivers for innovation are clearly safety, insulation, sustainability, and also we are trying to develop off-site solutions, so to say, again, ready solutions for the end users. I think it's called Building 4.0 or off-site buildings. And in order to achieve that, what we do our own market analysis. We constantly look for new ingredients. So if you are supplier, don't be shy, we are here. Clearly, also new ideas. And we perform internally a lot of tests, very many, prototyping things at a very small scale, lab scale, intermediate, medium-sized scale, and of course, also prototype at the industrial scale. We defend our ideas clearly, and at the end, we launch the product on the market. And as genuine research and development guys, our battlefield is the labs, both internal and external. And I might add also in collaboration with universities. If we don't have an instrument, we can, and we do, we make collaboration with universities all the time. You see the spaces are empty, but as a matter of fact, luckily for us, are crowded of very good, excellent colleagues, right, Solidea? Yeah. And so that's it. I thank you for the presentation. I leave you the place for the next one. Thank you very much.
Thank you so much, Bruno. We proceed with the nice fillers.
Buongiorno, sono Giovanna Di Giovanni, responsabile della ricerca e sviluppo di NiceFiller. NiceFiller è una PMI nata come startup all'Università di Salerno ed ha brevettato una tecnologia chiamata ChronoGuard, con lo scopo di aumentare la shelf life preservando la qualità e la freschezza degli alimenti. Oggi c'è il bisogno di sopperire a diverse problematiche come il rispetto dell'ambiente, quindi si richiedono packaging più sostenibili. La sicurezza alimentare, quindi dal packaging si richiede maggior protezione dalle infezioni alimentari pericolose. Lo spreco alimentare, infatti dai dati FAO 2021 possiamo dire che ogni anno vengono sprecati più di 900 milioni di tonnellate di alimenti. Quindi si richiede un packaging che aumenti anche la vita dei nostri alimenti. La soluzione a tutto questo è ChronoGuard. ChronoGuard è un additivo basato su un composto ibrido organico-inorganico, biocompostabile ed edibile. Questo è sviluppato per materiali in plastica, cellulosa, alluminio, utilizzati per il confezionamento alimentare. ChronoGuard riduce la formazione di biofilm, inibendo così la crescita microbica, allungando la shelf life degli alimenti, preservando le qualità intrinseche. Gli alimenti compatibili con questa tecnologia sono la verdura, la frutta, i latticini, i piatti pronti, la carne e il pane. Qui possiamo notare il notevole aumento della durata degli alimenti con la tecnologia ChronoGuard. Abbiamo un aumento anche dell'80%, del 100% con 10-20 giorni in più. I vantaggi di ChronoGuard sono tanti, come quello di proteggere gli alimenti dagli sbalzi di temperatura. Permette l'ampliamento geografico della distribuzione di alimenti freschi ed altamente deperibili. Aumenta la durata degli alimenti preservandone le qualità intrinseche, le caratteristiche organolettriche e nutrizionali. Riduce notevolmente l'uso di conservanti, perché non ce n'è più bisogno di inserirli negli alimenti. Inoltre è eco-friendly, che in base all'imballaggio utilizzato, questo può essere compostabile, recuperato mediante il riciclo del materiale o essere applicato ad imballaggi biodegradabili, riducendo così significativamente lo spreco alimentare. La ChronoGuard è una famiglia di prodotti, ciascuno adatto a specifici alimenti. Il punto di partenza sono i nostri filler. Questi filler vengono applicati, sono degli additivi che vengono miscelati a delle vernici alimentari o a dei master batch. Le nostre vernici vengono poi applicate con le tecniche di coating su film polimerici o a mezzo stampa su carta e cartone, mentre il master batch è un polimero di base in granuli, al quale viene aggiunto il nostro filler, il nostro additivo, che viene fuso e laminato per produrre film plastici con la tecnica dell'estrusione. Il mercato del packaging alimentare è in continuo aumento sia in Italia che all'estero, quindi si prospetta per ChronoGuard vaste prospettive di mercato. Stiamo già lavorando con diverse aziende sia nazionali che internazionali, come il Giappone, il Cile, l'Olanda, la Svizzera, su diverse tipologie di alimenti e di materiali, cercando di creare nuovi prototipi e preserie con diverse tipologie di packaging. Non esiste una concorrenza diretta di ChronoGuard, ma esistono altre tecniche per l'allungamento della shelf life, ognuna con i suoi limiti ed i suoi vantaggi. Con tutte queste, ChronoGuard può agire sovrapponendo gli effetti. Questo è il nostro team. Abbiamo la titolarità di 3 brevetti, i primi 2 sono già a livello europeo e riguardano il primo riguarda il filler concesso nel luglio 2018, mentre il secondo riguarda l'applicazione del filler via coating concesso nel settembre 2019, il terzo è ancora in fase di espansione a livello europeo e riguarda la tecnologia applicata su carta e cartone, ottenuto nel febbraio 2022. Ecco, appunto, il nostro obiettivo è quello di un'economia circolare del cibo che può produrre una serie di vantaggi non solo etici ma anche ambientali. Tra i tanti è proprio quello di dimezzare lo spreco alimentare entro il 2050. Grazie dell'attenzione.
Thank you again, Giovanna, to these 4 companies, I'm sorry, that agreed to share their kind presentations with us. So other than the 4 companies that talked so far, there are a few others that also kindly accepted to verbally, orally provide a small presentation of their companies. We're going to start with the Riestag. I'm so sorry if I'm pronouncing the names incorrectly. No? No? Shy? It's okay. Don't be shy. No, it's fine.
Can I introduce?
Of course.
Yeah, okay. Vestac is a company that works in the construction sector, correct? And works on the application of insulating materials in several sectors, mainly in construction field And there's anything else, qualcos'altro che posso dire di voi? Is a company that at the moment is located in Campania. No, se vuoi mi dai qualche altra informazione così giusto per... Se vuoi. Giusto perché così si sente.
Okay, I repeat, Restag is a company founded in 2010 for the saving energy reasons. So we do apply insulating material into construction fields. We do the design and the application of the products. And we do also great restaurants, infrastructure for the public infrastructure, schools, town halls, wherever is needed an efficiency improvement in terms of insulation and energy saving with new age conditioning plants and renewable energy plants like PV plants, geothermal, or small hydro or wind farms.
Thanks. Second one.
So that you can hear me, I hope. So next we have 5.
Alfonso, don't worry.
Yes, also.
So, my friend, possibly.
Okay.
The representative.
Okay, my name is Alfonso Arrigo. I'm working in Pozzerosio. Pozzerosio is a part of a Poz Industries group. We are a system house. We produce più polyurethane for discontinuous in continuous. Sometimes we can supply isopan, not separated because it's auto formulated. So, and we work also. We have also SIPE as a partnership in our group. That is a company that produce machine for laminator and also for discontinuous application. Our big competitor are names like Canon, Krasmafei, Heineken. We are here because we are innovating and we are looking for biomaterial in order to produce polyurethanes with a high percentage of bioproduct. In this case, also we presented in AMPE, Italy, our technology, Repur, where we are using the waste material come from production, and we produce a panel with the waste product. Okay.
Thank you.
I believe that the last speaker also spoke about polyurethane.
Yes, both.
So next we have Trinseo.
Hi, just a short presentation from myself. My name is Giovanni Forte, and I work for Trinseo. This was the nickname when I worked here. And Trinseo is a company present all over the world and has a broad range of materials. Among them, there are rigid plastic for automotive, latex, PMMA, and a small piece of the cake is related to elastomers. And the site is in Mussolente, Vicenza, and we produce TPE, TPU, and TPU compound. And we are very focused on sustainability. and we have a broad range of materials with a large bio content, and we are focusing our strength on recycling TPO.
Thanks, John.
Grazie. Next we have Spoof.
Qualche parola?
Salve, sono Raffaele Calafiore, commerciale della Spoof Cristiano Group. È un'azienda che praticamente utilizziamo questi materiali nell'ambito del complemento d'arredo dell'arredamento. E, niente, siamo in provincia di Caserta, una piccola realtà artigiana con 20 anni di storia, microstoria alle spalle. Grazie per l'invito e buon lavoro.
Can I translate? Spoof is a small companies that works in the sector of the furniture, in particular related to the transformation of the polyurethane foams for sofa and other application of soft polyurethane foams.
After Spoof we have Multistint.
Buongiorno, sono un'azienda che trasforma poliuretani espansi, sono un trasformatore, mi trovo nella zona di Nola, lavoriamo sul territorio Italia, in particolar modo anche nelle isole europee, quale Malta, Grecia, come trasformatori sia dei poliuretani in qualità tecnici tipo microcell o in grandi celle che vengono utilizzati per i filtri di acqua come anche di aria. Poi passiamo anche a quello che sono i poliuretani in trasformazione per i divani, i sofà, intesi micro sofà, oppure per il settore letto. Per questo naturalmente ci rivolgiamo anche a tutto ciò che sono altri semilavorati, quindi entriamo anche nell'ortofrutta, spallinifici e tutto ciò che riguarda spugne. Grazie.
And last but not least,
three words for the Multisyn in English. Okay. Also, Multisyn is a company that works on the transformation of polyurethane foams, but also the transformation of the polyurethane foams, flexible and soft polyurethane foams. They produce also filters based on polyurethane foams. Okay. Last one.
last but not least, we have Labec Design.
We are Labec Design, is a startup works in the 3D printing sector, making use of polymers of different nature, including thermoplastic polyurethane fillet. We also use it printing to create crate forms for complex geometries in construction sector, within which polyurethane is also loaded to make thermal or acoustic insulating walls and small furnishing objects. We are interested to understand in understanding if your bio-based foam materials can be inserted in our geometries. Thank you.
This is for me. So next, we have a brief presentation of BIOMAT. So, as mentioned earlier, I'm Juliana Oliveira. Yes, it does. Maybe I need to speak closer to it. Yes? Perfect. Sorry. So my name is Juliana Oliveira. I work at CENTI, which is the Center for Nanotechnology and Smart Materials located in Famalicão, Portugal. I'm talking to you today as the representative of BIOMAT's coordination team to present to you our projects and open innovation testbed, and to share our available services and advantages to future customers. I'll start by giving you a brief introduction to BIOMAT, which is the open innovation testbed for nano-enabled bio-based polyurethane foams and composites. BIOMAT, as Letizia said earlier today, is a European project. We are built of a consortium of 26 partners from all across Europe, which includes SMEs, LEs, universities, research centers, and a standardization body that came together with the common goal to establish an open innovation testbed, which is BIOMAT DB. The goal is to provide services to a wide range of European industries and motivate the uptake of innovation in nano-enabled bio-based cellular materials, so polyurethane components, foams, and composites, placing strong emphasis on sustainability, circularity, and renewable resources. We aim to do this for the top 5 markets with the highest demand for these materials, which are building, construction, automotive, furniture, and bedding. So BIOMAT will combine biomaterials, upgraded technologies, with the aim to answer the increasing requirements of these very demanding markets. So the main idea behind the project is to explore sustainable alternatives to the production of foam products. And we do that by taking broadly available low-value residues from agricultural and forest industries. We extract compounds of interest, such as silica, lignin, cellulose nanocrystals, and vegetable oils, and then use them to produce nano-enabled biocomponents and materials, namely prepegs, bio-based polyurethane foams, and bio-based composites, lineoadhesives and adhesive promoters with appealing properties such as flame retardancy, antimicrobial, hydrophobicity for the construction, building, automotive, furniture, and bedding industries. So these high-performance materials can then be used in new value-added products such as sandwich panels, insulation aerogels, seat cushions, sofas, mattresses, etc. Last but not least, due to the use of renewable resources, these new bio-based products have the potential for reuse after sustainable recycling processes. So I mentioned that BIOMAT is an open innovation testbed, but what is an open innovation testbed? This is a very key point that might be a new concept to, of course, not the partners that we have here present, but for the kind SMEs that agreed to join us and the ones hopefully following on our online stream. So an open innovation testbed is a set of entities that come together to provide common access to physical facilities, capabilities, and services that are required for the development, testing, and upscaling of technology, nanotechnology, and advanced materials in industrial requirements. So all of our partners come together to provide this, the development of these new nano-enabled advanced products, and also the upgrade of technologies, and provide them to companies and individuals that might not have direct access or easy access to this sort of developments and products. So we provide validation at lab scale, so at a lower TRL, in this case TRL4, and then we go on to produce prototypes and validate them in industrial environments up to higher TRL, so in this case TRL7. Why open? So I said it was an open innovation. So open access means that any interested user can access the testbed facilities, capabilities, and services at fair conditions and pricings, and with transparent mutual obligations with regards to security, safety, and IT rights. Any individual, team, or institution from academia, research organizations, small and medium enterprises can participate or take advantage, profit from this Open Innovation Testbed. So after all this, what does BIOMAT TB have to offer? So as you can see here, we have services and technologies that will soon be available for customers through our testbed. It's a very polyvalent catalog of services with the goal to provide support in all aspects of product development, from lab to pilot scale and even into industrial scale, covering the entire value chain from basic materials and functional nanoparticles up to the final product for the 5 targeted sectors that we've mentioned so far. As you can see here, the services are divided into 2 main categories, so the transfer technology and the horizontal services. And what comes to the technical services, BIOMAT has 12 pilot lines dedicated to the pilot scale production and recycling of nano-enabled bio-based cellular materials, through which we'll be able to support SMEs to implement innovation and nanotechnology into their current processes. The horizontal services include those of business support, such as chemical, structural, and surface characterization of foam products, digital twin pilot implementation, which might be a foreign concept, but you'll have the opportunity to learn a bit more about it during the course of today. Inline monitoring, nanosafety, and toxicity evaluation, as well as knowledge transfer services, including LCA and LCC studies, and support in fundraising, business, marketing, and intellectual property rights. The complete catalog of services will soon be available for free consultation on BIOMAT's website, so keep your eyes open. How can SMEs have access to all of these services? So BIOMAT will be operated through a single entry point, so the BIOMAT CEP, which will act as a point of contact between future customers and the service providers, so all of the members of the OITB that I've mentioned previously, and will allow open access to a wide range of the facilities available and the horizontal and technical services at fair conditions and competitive prices. Now, the interesting point, and the one that we want to get across to all of our SMEs kindly present here today and at home, is that also during the BIOMAT project, we will validate the operation of the CEP and of the services that we are upgrading through the implementation of an open tender. So the open tender will serve as a sort of beta test of our Open Innovation Testbed. And we will do that by providing services free of charge to selected customers. So very simply, interested customers will be able to apply to open calls that will be launched from December this year through a web-based platform of the CEP. So after an internal process of evaluation, between 5 and 8 customers will be selected to receive the services free of charge. So all of the services that you will have the opportunity to see today will be available to you free of charge through application to these open calls. And once the customers are selected, an agreement will be signed between customers and the CEP to define the details and of the provided services. And then the selected customers will be directed to their respective service providers within the BIOMAT testbed. So the results should be delivered to customers between 3 and 6 months, depending, of course, on the length of the service selected and the requirements of this service. As you all are having the opportunity here today, we are putting strong emphasis on the promotion of this open tender through SMEs and through these events that we are creating, workshops and others that we have foreseen for the project. So it's advantageous to us that allows us to disseminate our project and OITB, and also advantageous, we hope, to you, that you'll be able to profit from our services free of charge. So I think this is all from me now. You'll hear more from me a bit later. So if you wish to know more about BIOMAT OITB after the workshop, of course, and the opportunities that we'll have available for SMEs and the services of our catalog, you are always welcome to access our website and reach out to us by email or through our social platforms. We'll be happy to clarify any questions and provide the assistance that you need. So thank you so much for your attention. And now we'll proceed with a small coffee break. Yes, Letizia? Yes. And then we'll present all of the pilots so that you have detailed information for everything we'll have available. Thank you so much, and see you in a bit.
Corrado. Okay, that's all. Can we restart?
Yes. I think I'm gonna have to use this one because this one is not on yet. Huh? Oh, I can start with this one and then now. Here you go. Hello again. So now can you hear me? So now we'll proceed with the presentations of the 12, not 12, because we unfortunately don't have them all here today, but most of the pilot lines that we'll have available at BIOMAT testbed. We have actually a small change in the order of the pilots because due to some time restraints, we'll have to present PL7 first. It's not really because I want I don't want to monopolize the workshop, but we'll start with Senti's pilot line. So Senti, besides being, as I said, the coordinator of the project, we are also in charge of one of the pilot lines that we'll have available at the BIOMAT testbed. Our pilot line is dedicated to the hydrophobic, flame retardant, antifungal or antimicrobial biosilica nanoparticle production. So just a quick intro to Senti. We are a nonprofit research organization located in the north of Portugal, as I've mentioned. Our strongest points, our know-how is in the field of nanotechnology, biotechnology, and service engineering. We work in the development and scale-up of innovative materials, device, and technologies, and we have a lot of experience in the upgrade and industrialization of innovative and emergent technologies. Within the scope of BIOMAT, we are applying our know-how in valorization of industrial residues, in this case, agro-industrial residues, for the obtention of silica nanoparticles. We also have solid know-how in the synthesis and functionalization of nanoparticles, both silica and other materials. So the pilot line in BIOMAT TB is dedicated to the extraction of biosilica particles from agro residues, mainly cereal husks such as rice husk and straw, and then the modification of the extracted silica nanoparticles to impart different properties such as hydrophobicity, antifungal, antimicrobial, and flame retardancy. Of course, within the scope of BIOMAT, our focus is in the sustainable and circularity use of widely available and low-cost feedstock, in this case, agro residues that would not be valorized other way, within the upgrade that we've been performing in the scope of BIOMAT, our maximum pilot production is around 300 grams of nanosilica particles per batch. This might not seem like a lot, but trust me, these 300 grams of functionalized silica nanoparticles implies the processing of a lot of rice husk. So just to give you an idea, only about 10% in weight of rice husk is actual silica that we can extract. Of course, there's a bit of loss of silica in the process. So you have to process a lot of rice husk in order to have a lot of biosilica. As I've mentioned, we are able to provide this particular technology at lab scale up to pilot scale. So starting at lab scale at around 5 grams per batch in yield using a 10-liter reactor, and then up to 300 grams per batch using our pilot and industrial scale reactors of 100 and 600 liters. Also required to this process are a couple of other significant infrastructures and technical equipment that we currently have working at Senti, such as a 216-liter high-temperature oven to do the calcination of the silica, and a 6-liter centrifuge, so that we can separate, of course, the silica from the reaction medium. Other than providing the technology and providing the product component filler, so to speak, so the biosilica and the functionalization of the biosilica. Of course, parallel to that technology, we also provide the product characterization. We have several common usual methods available, such as FTIR, TGA, UVVs, DLS. We can also provide SEM, the characterization by SEM, the characterization of the antimicrobial activity, contact angle measurement to assess the hydrophobicity of the materials, and of course, the assessment of flame retardancy for flame retardant functionalized nanoparticles. These materials are applied within the scope of BIOMAT as fillers for polyurethane foams of different types, soft foams, hard foams, that are then applied to different pilot demonstrators within the project at the key target markets that we have at BIOMAT. You can include, for example, the antifungal and antimicrobial nanoparticles in foams that will be used for sofas and mattresses to provide an antimicrobial and antifungal activity for the prevention of rotting, biocorrosion, harmful odor-causing bacteria. Other example of application can be also in the stuffing of car seats. Of course, flame retardancy functionality and application, as it was mentioned by one of our SMEs today, can be applied in hard foams used for insulation. Of course, also in bedding and the car seats. And then hydrophobicity for the prevention of water absorption and humidity, which can then lead to the corrosion of the polyurethane foams. Other than these particular applications that are clearly geared towards BIOMAT's objectives, we can also, this is quite a polyvalent technology, we can also apply these nanoparticles with different technologies and for different applications. We can use surface modification of different types of substrates using different type of coating technologies. So I would give as an example, spray coating, deep coating, for example, in textile substrates or other polymeric textiles that can be used, for example, in packaging. So we can apply these, for example, an antimicrobial functionality on a packaging can be something quite interesting and appealing to a number of industrial applications. And of course, we can also use these nanoparticles as additives in formulations. One of example within BIOMAT is using these as fillers in foams, but of course they can also be used as additives in paints. This is just one example, and many others in coating technologies for surface functionalization of a number of different substrates. So this is just a quick example and a quick description of what we'll have available at the Senti's pilot line. Of course, if you have any questions or any questions whatsoever, please feel free to contact Senti. We'll be sure to provide all of the help that you might need. This is all from a pilot line 7. We'll now proceed with a pilot line 1. Okay. CNR IPCB. Thank you so much.
So, can you hear me? Good morning, everyone. My name is Giuseppe Cesare Lama. I work at CNR here at IPCB. And today we will present our pilot line, which is, as Juliana said before, one of the 12 we have within our BIOMAT project. So we actually have pilot 1A and 1B, and we will go through them during the presentation. Our organization as EPCB CNR, we have experience with polymer materials, composites, and nanostructures, in general with functional properties. Also polymer materials with multi-phase biosensing for tissue engineering, also regenerative and therapeutic medicine. Also processing technology for polymers, both synthetic and natural, for composites and nanostructured. Also the synthesis of functionality for polymers and nano-enabled particles. And also we can perform some structural characterization of both molecules and the whole materials in terms of mechanical properties and thermal properties, as well as the dissemination and transfer of technology. So pilot 1A is the big brother, big one. It can arrive to produce panels with a concentration of fillers up to 60% in weight. It consists of two main units. There is a unit in which there are stored both component A and component B, so polyols and isocyanate. And then there is also a filler storage. These three components are mixed together in a sequence, in a precise sequence in our extruder, and then a panel is obtained. This is some pictures in which we can see in yellow the silos, which contains both component A and component B, and in red is the extruder where the mixing between the filler used with the polyols is highly intimate. Then, after the mixture is extruded, is let it foam, and then is demolded. Then the little brother, pilot 1B,
This one is a little, in which there is a hopper dedicated to the fillers, and then the polyols with the additives, so the component A and the component B are present in two tanks separated. And then, thanks to two different pistons, is used and poured into a mixing chamber. This is the main figure, and now we must go to the video that unfortunately we weren't able to upload to the presentation. So this is the main plant. Here you can see the pump, thanks to which we can take the material. This is the hopper for the fillers, and this is the control panel of our material. This cylinder is the reaction chamber in which the reaction takes place, and those are the two pistons that take the components from the two tanks. This part is moving because this part is going directly into the mold, in which the material is then released all at once. Here we can see the pouring of our samples, of our fillers, and this is how it is mixed, the material. At the bottom is the mold, which is 1 meter per 70 centimeters, and this is how the material is about to grow. So this is the volume we are talking about. Letizia is showing us the sample. So this is the amount of the higher percentage. So 20% in content of a filler will be poured now. And as you can see, the mixture here is more viscous, now you can see the pouring of the material, 3 to 1. Here it is. So in this way, we avoid losing the lowest part of material, and this one avoid to contaminate the foaming process with an unreacted material. This is, of course, speeded up the growing of the sample, and the dimensions. Maybe you know. These are our dimensions. This is with the 20% filler and the same amount of the previous one. And the reason why it grows is because the filler, it was in a higher amount, and it was actually full of water. So our main products and characteristics in terms of material, final material, we are producing bio-based composite polyurethane foams using biopolyols and bio-based fillers, or the filler coming from other industrial lines. The one you saw are coming from construction lines, are side byproducts of construction line materials. The performance for our pilot are mechanical properties comparable with those of the standard materials, good thermal stability and good thermal insulations, as well as the fillers are also homogeneously dispersed within the foamed matrix. Moreover, from a sustainability point of view, we have reached a bio-based content up to 50% with the complete replacement of the petrol-based polyols that are present in component A. With the other relevant application, as we said before, we are using this kind of material as acoustic and thermal insulation, as well as for rigid foams. For semi-soft foams, we also have the application in, we can say, in most part of the car, so the headliner, the textiles, and also in the dashboard and in the steering wheel, as well as in furniture and in design. So this is it from us. Thank you very much.
Thank you, Peppe. Okay, the next speaker is Sergi, HSK.
Hello, everybody. I'm going to represent here very briefly the pilot line for development and upscaling of nano-enabled bio-based polyurethane soft and semi-soft forms for bedding and furniture applications. Regarding the expertise at our University of Applied Science, I decided just to put the groups related to the project in order to expand our whole expertise at our faculty. As you can see here, in the project are groups involved dealing with elastomeric materials, hybrid and multifunctional materials, as well as with textile engineering, because we also are involved in another part of the project, developing reinforcement materials for composites based on natural fibers and basalt fibers. If you want, later on you can see here on the table some examples of our actual or common development, some non-woven based on flax and basalt fibers with different content of basalt fiber, and some representative forms, for example, nano-lignin reinforced forms containing exceptionally bio-based polyols, and sometimes also we are using bio-based isocyanates. So here some pictures of the producers of the line we are going to install in this July at our facility. The pilot line is very flexible and very compactly constructed, and actually is able to manage the formulation of the form even inline. We also will include the CO2 forming technology, being more and more popular around the world, and we also will get some cutting module in order to cut our blocks to the desired shapes and provide them to our partners dealing with the characterization and with development of demonstration products. If you want to take a picture, please. So I'm not sure if you can see the values here in this table, but I would like to stress here the flexibility of the pilot line is related to the fact that we design it using 90 separately controllable metering lines. You can see here we decided to include 4 metering lines for polyol components, including more viscose ones. This could be polyester polyols. It's small addition to classically polyester polyols for our application, or nano-reinforced polyols, what is actually also one of the big goals in our project. We also have 2 lines for isocyanates, classically KDE, MDE basis, but I have to stress here that MDE line will also be able to measure higher viscosities when we are using prepolymers. So we have collected already the experience with commercial prepolymers of MDI in combination with biopolyols. So we have promising results. So that's why we expanded in the last time the viscosity range for this metering line, and classically for almost all important additives in our formulations. And here CO2, this is this patented NovaFlex CO2 forming technology. And of course we need also nitrogen to protect our system from humidity. So here you can see also that the line is able to operate in continuous mode or discontinuous, so batch mode. In the batch mode, the average shot volume is dedicated to 5 kilograms per batch, but depending on the viscosity of the whole formulation, it could range from 2 to 25 kilograms per minute. The maximal continuous production speed is 10 kgs per minute, but in fact we can also go to 20, but we would like to stay to more nominal 10 kilograms per minute, because in this case we can easily transfer our processing parameters to industrial process. And regarding the metering lines, the metering line 1 for standard or basis polyol can be operated with a maximal metering output of 15 kgs per minute. The main products we are oriented in the soft and semi-soft forms, both elastic and viscoelastic, for furniture and bedding applications, and as a demonstrators we selected sofa, chair and mattress. So that's why I just listed here the performance related to the pilot line itself, and we can realize with this the development and upscaling of polyurethane forms, including nano-reinforced and classically filled ones. For example, for the UK, the flame retardant forms are very important, and classically they're using melamine or phosphate-based fillers as a flame retardant. So one metering line for viscose polyol components in our line is also designed with a mixing device in order to keep the system homogeneous and avoid sedimentation, and we also have some line to clean the pipes of this metering line after using it. So any sediment inside the line is avoided in this case. What is important to know, at our line we can investigate all the components. Classically there are companies which are interested in development of additives, and that's why we can routine and very quick investigate the influence of different additives, new additives on the forming and performance of the related forms, or we can also investigate the new basis components, isocyanates and polyols. And very important is that we can optimize the processing parameters being very close to those used in industrial slab stock production lines. We also have not fully automated line, a semi-automated line, because we have to touch some buttons there and so on. And this is also providing big flexibility. And regarding the sustainability, we are going to use as much as possible bio-based materials. You can see here from polyols to fillers and additives, but also, as I said, we are also including already commercially available bio-based isocyanates. We are using sustainable blowing agents, and the next benefit of the pilot line is very small losses on the materials, because it's very compact constructed, and many of materials are really valuable and expensive, and thanks to this we can also spend obviously less time compared to manual investigations or investigations on semi-industrial lines. So here, just to give a look, you can see here this sofa. Our very first demonstrator in the project is built on our first promising bio-based polyurethane foam. Just representative samples, you can see here some of them also here on the table. After the workshop, you can touch them and evaluate and so on, etc. But in fact, we, as I said, we selected the demonstrators, a sofa, a chair, and a mattress. So regarding the other relevant applications, actually our line could also be partially used for creation of rigid polyurethane forms. Our cutting module is also able to cut all types of polyurethane forms. That means we can provide services also for variety of other industrial sectors. And even without using the blowing agents, we can formulate the polyurethanes for casting applications using this line. So that's all. Thank you very much for your attention.
Thank you, Sergi. Thanks. I want to say that all the presentation will be available on the website, I think. Yes? Or yes. Perfect. Okay, the next speaker is Dario Cantero from UCLM.
So can you hear me? Yeah. Well, good morning to everyone. My name is Dario Cantero, and I'm the representative of the University of Castilla-La Mancha that is going to talk about our pilot plan. So our plan is based over the insulation aerial panel productions through the freeze drying technique. First of all, I'm going to talk about the research team that is involved in this project. All of our staff is part of the permanent staff of the Department of Chemical Engineering at the University of Castilla-La Mancha. In the field of conventional and electrochemical catalysts, our team has some experience in the alcohols reforming, the Fischer-Tropsch, and the water gas sieve, among others. It has gained expertise in the synthesis, formulation, and characterization of carbon and carbon-nitrogen nanostructures, in the production of aerogels and other composites, and in the production of encapsulated materials and catalysts. This profile allows our research group to develop some new synthesis routes for carbon nanostructure materials, to develop some new synthesis of inorganic materials such as nanosilica, or to design, simulate, scale up, and optimize some different chemical processes. Our pilot plan allows us to go from lab scale with a production of 0.36 square meters of aerogel per batch up to 2 square meters of aerogel per batch using our semi-industrial freeze dryer. It's need to say that this final production depends on the thickness desired for the resulting material. Our pilot line is based over a semi-industrial freeze dryer, as I have just said, which is a compact unit with casters made of a steel stove-enabled cabinet. It has a vial stoppering and spacing device, an isolation valve to condenser, a microswitch software, and a vacuum pump with exhaust filter. The system allows to control the freeze dryer by a human machine interface, that offers information about the system elements such as the valves or the indicators of the equipment. Outputs alarm information, allows to modify the parameters of the freeze dryer cycle, and protects the system from unauthorized use. It also allows to do some research development depending on the material that, with which we are working. Also, there is installed a vacuum sensor to control the pressure of the product environment, enabling the characterization of the scale-up results. Monitoring the experimental conditions is also possible in the pilot line, just to check the physicochemical properties of the resulting products. And finally, the system also allows to control and improve the energy consumption during the cycle. So this pilot line allows to obtain some value-added products while looking after the sustainability throughout all the process. It is achieved by using a solvent-free process, using water as a solvent, not using expensive reagents, with environmentally friendly synthesis routes, and all while reducing the energy consumption during the process by controlling different parameters of the plant. In fact, this aerogel production synthesis consumes a less amount of energy than other production routes, such as the supercritical drying, all while obtaining some very similar products. So it allows us to obtain those products while looking after the sustainability of the process. The main product of the plant are aerogels, which are ultralight materials with very high porosity and very low density. Those characteristics gives the aerogel some appropriate properties to be used in several industrial applications. Some of these applications are, for example, on the thermal insulation for exterior walls on buildings. UCLM has produced some different type of aerogels. On one hand, we have produced some organic aerogels, such as the polyimide, the polyvinyl alcohol-based, or the polyurethane-based ones. And on the other hand, we have some inorganic aerogels, such as the alumina cellulose aerogels. The ones that will be used in this project are the polyurethane-based ones. We have some different characterization techniques to check the properties of the resulting product, and also to check the properties of other products that we are not developing, but can be sent to us externally. First of all, if we talk about the morphological and physical characterization, we do some density determinations, a SEM, an FTIR, and a mercury porosimeter. For the mechanical characterization, we use a dynamic mechanical analysis, a DMA. And finally, for the thermal characterization, we have a DSC and a TGA. So low density and high performance thermal insulation biocomposite aerogel panels will be developed by the University of Castilla-La Mancha and validated by Acciona and Ritols using mockups. These aerogel panels will be installed following the current thermal insulation specifications and guidelines of exterior walls, thus providing an efficient and an energy-saving solution for this insulation of exterior walls in both new constructions and the renovation of older structures. Finally, if we talk about other relevant applications of these materials, we can talk about the construction sector, about the automotive sector, and the aerospace sector, apart from the insulation for buildings that I have been talking about. These materials are working in all of these applications as thermal insulators, but they can also be used as acoustic insulators. So that's the end of the presentation. Hope you enjoyed, and if you have any questions, I'll be glad to answer to any of you. Thank you.
Thank you, Dario. The next speaker is IVW. Ludmila?
Materials. Not enough loud. Okay. I'm Ludmila Grishuk from Institute for Composite Materials. We are also involved with We are also involved in this project, is this big project BIOMAT testbed, and we are make development of the pilot line for nanofillet polyol and resin formulation. We are from west of Germany, from southwest of Germany, from the region where people produce very good wine, very good composites. It's our institute. Composites for automotive, for constructive, for aeronautic, for medicine. Some people play football, not so effective as we develop composites. But in each project, we need experience, we need expertise. And for this project, we are very happy because we have excellent team, as always. And in this team, we have also so many technical people that have so many experience, they have so many practical knowledge. It's a niveau of professors. And we are happy that we have Heidrun in our team, we have Petra in our team, we have Claudius, Frisch master that are very good in atom force microscopy and nanocomposites. And our wishes, for our wishes always say yes, Bernd Wetzel. We are for this project for preparation for development of dispersion procedures for different cases. We can make good dispersions for polyol blends, fillet, non-fillet, of resin, bio-based resin fillet, not fillet, for preparation of foams, for preparation of bio-based composites. And what is good for our pilot line? We have pilot lines that are built with different blocks, and these blocks are fully independent. We can use all 4 blocks, we can use only 1, we can use 2 or 3, but we can also use these blocks in different order. And for us, it's important that in short time, we can produce good dispersion, and of course, we must be sure that this dispersion is good, and this time of mixing, of dispersing is enough, and is enough time for this preparation. That's why we have also included different analytical methods for control, also inline control and characterization of our process. We can start with 3-roller mastificator with mill, and this mill is best of the best method for preparation of high fillet dispersion, especially if we work with such expensive and such sensitive fillers as, for example, graphene or a carbon nanotube. For preparation of dispersion of such materials, we have very high risk with classical dispersing that we destroy this material. If we use this mastificator, we can prepare dispersions which has up to 50% of filler, but this preparation is very, very sensitive, very, very delicate. Also, if we have very high concentration of dispersion, we have very high concentration of filler, we can prepare this dispersion, this formulation on request, and if we have very good dispersion, we can be sure that in this case we have very slow agglomeration because viscosity is very, very high. Next block is ultrasonic dispersion assembling unit. We have a flow cell, we have ultrasound finger, and we can disperse our materials with ultrasound. We can make regulation of velocity of flow. And in this case, we can work with different fillers, and especially with fillers that are very strong agglomerate. This pilot block is suitable for also for dilution of master batches, but also is work very good for preparation of nanofillers in polyols, dispersion of nanofillers in polyols and different resins. Of course, one of the best is the rotor starter principle for preparation of dispersion, and this principle we have in set block in Istral Pilotech plant, and we have inline mixing dispersion, and additional we have also wet milling for completely deagglomeration of powders in suspension. This method is very good for low and medium viscosity products, and we can work with high speeds up to 14 cubic meter per hour, and peripheral speed up to 60 meter per second. And we can work in small amounts, 5 liter up to 70 liters per batch. Biggest machine is our pilot line, is dissolver. Dissolver de facto is big mixer, and with this big mixer we can dilute our concentrated dispersion, or we can prepare from zero new dispersions, and this mixer has very, very high shear forces. And due to these shear forces, we can disperse and mix all components of polyols or resin formulations. We can mix up to 200 kilograms per batch. What is very good in this case? Some dispersions, some polyol blends for foam preparation have blowing agent. And normally, blow agent is blow agent while air had because he has a very low boiling point. In the case of dissolver, we can cool down our mixture, and we can have stable temperature, and we can also have temperature lower as room temperature for mixing and preparation of our dispersion. We avoid evaporation of our blowing agent. Next SIG Plus for this device is, for example, epoxy resin preparation mixing. By mixing of epoxy resins is very big problem that we have gas bubbles. And if we cure such system, product has defects, and these defects decrease significantly mechanical properties of our purate resin. And in this case, in the case of dissolver, we can, with vacuum, pump the gas, and we can avoid building of defects of pure resin. Okay. Main products and characteristics that we can, with our pilot line independent, we are flexible with this pilot line. We can prepare high quality dispersions of nanofillers, and we can make inline quality control and optimization of process parameters. We can work not only with bio-based resins, not only with bio-based additives and polyols. We can work with all products. We can mix all together. And this inline monitoring gives us possibility to optimize processing cycles. I don't know why I have lost my slide. Okay. Maybe it was wrong file. And some words about characteristic, about analytical devices. For each process, for each resin, for each dispersion, we must to have a ground characteristic, and one of these characteristics is viscosity. And we can control also viscosity of our products. And it's my this my loveliest device is zone for inline monitoring. In this zone, we can use in small amounts, a small beaker, 100 milliliter, and we can use in 200 liter dissolver to control of mixing. What makes this device? This device count particles, amount of particles, and controls the size of particles. Also, it's very important that for this device, not matter which type of particles. Normally, a classical DLS method, for example, is developed for spherical particles. If we have other form of particles, control is can be a problem. And in this case, we are free. We can control mixing of all types of particles. Also, if we have 2 types of particles or 3 types of particles, and we can see, okay, after 15 minutes, we have no change in amount of particles. We have no change in size of particles. That means it's enough to mix it. And we can control this process for 100 milliliter, for 1 liter, for 20, for 100, 200. And in this case, we have quasi-extrapolation, how many time we need to have good dispersion with this device or with other device for preparation of good product. Next step to control of our product is also stability of our dispersion, because dispersion is not solution. Dispersion has particles, and always we have minimum 1G. And for example, for polyols blends, it's very important that we have one phase, we have not phase separation during minimum 3 months or 6 months. We cannot wait 3 months for each batch for new developed formulation or 6 months. With this device, we can increase the sedimentation or increase phase separation, and then say, okay, after for this dispersion, after 2 months, we have for this dispersion, we have after 2 months phase separation. We need to improve stability. We need to improve formulation. We need to look for other emulsifier or maybe for other components. And this device gives us possibility to use 2300 G, up to 2300 G. The factor is a small centrifuge. This can work 72 hours, and we can see sedimentation of our particles, or we can see formation of two phases for our product. Okay. If you need good dispersion, if you need mix one or more components together, we are right people for this. And we can make not only dispersion for nanophylic dispersion in polyols for foam preparation or resins for composites. We can also make blends for coatings, adhesive preparation. And we work for different industrial sectors, because main idea of our institute, from fundamental research up to industrial application. Thank you very much.
Okay, we move very quickly to the next speaker. Is UPC, Silvia.
Hi everyone, my name is Silvia. I come from Barcelona, from the University Polytechnic of Catalonia. Today we'll present the pilot 9 and 10 related to sono-enzymatic production of lignocellulosic adhesive and or internal adhesion promoters. Pilot 9 and pilot 10 is the result of the UPC expertise in enzymatic functionalization of polymers and biopolymers, and also combined sonochemical biotechnological process for antimicrobial coating productions and nanomaterials. So this expertise was acquired within different European projects and resulted in several patents and papers. So pilot 9 is a pilot to enzymatic production of lignocellulosic adhesives and promoters. This pilot consists is basically a bioreactor with a volume of 30 liters with different kind of steering options. We also have a control unit for data recording, calibration, etc., that will help us to optimize the processes. We can control and measure the pH, the amount of oxygen and temperature. Also, this temperature is controlled with a water jacket. So we use this bioreactor to scale up enzymatic process to modify lignin with natural phenolic compounds as gallic acid and tannic acid to improve the reactivity and the properties of this lignocellulosic biomass. So we are currently using this 10 liters volume, performing the reaction, this catalytic reaction at 55 degrees. We also increase the amount of lignin that we can process to 30 grams per liter. So why it's interesting this process? Because it is a green process that does not use non-toxic substrates. It's a water-based reaction, and it's a fast reaction. It is catalyzed by a natural compound, these enzymes, and the products are non-toxic also and can be reused for another processes. Pilot 10 also continues with this philosophy, and in this one, it is consists with ultrasonic reactor. This is works in not in batch but in continuous flow cell. It is equipped with a peristaltic pump, and also we can control the temperature and other parameters to optimize the processes. We use this pilot to functionalize and nanotransform these lignin residues. Also using this lacase, this natural catalyst to nanotransform and modify the surface of the nanoparticles. So here I present the setting of this procedure that we scale up using Pilot 10. Again, we are using a reaction that is non-toxic because it does not use natural compounds. It is water-based, and again, these products can be reused and recycled. So Pilot 9, Pilot 10 is completed with a freeze dryer and centrifuge to purify and dry these obtained products, because in some applications it's interesting to have it in solid form, these nanoparticles. So summarizing, the main products that we obtain is from lignin. We can enzymatically functionalize this raw material to increase the reactivity and the compatibility with different polymeric formulations. We can nanotransform this lignin to fillers that can be incorporated in these formulations. But again, also combining this nanotransformation in Pilot 9 with this enzymatic procedure, we can nanotransform the nanoparticles and at the same time functionalize the surface of these particles. We tested and we scale up the process with lignin, so we are able to provide this kind of filler that we show here. But we also tested with hemp, linseed, and sunflower, and we obtained good performance with this modification. So the main products that we obtain is phenylated lignin nanoparticles that can be used as lignocellulosic adhesive and internal adhesion promoters. With this modification, we enhance the reactivity and adhesive performance, and they are more suitable to be introduced in polymeric formulations. So these particles can be, these particles and this lignin functionalized can be used to prepare foams, bioresin, nanocomposites, and sandwich structures. Why is interesting this process? This process is versatile, is green, and can be adapted to different final applications. And also we can introduce different functionalities using this enzymatic procedure. We can obtain nanoparticles and raw materials with flame retardant properties, hydrophobicity, and also antifungal and antimicrobial activity. We also can use these pilots to chemically modify a wide selection of biopolymers, such as chitosan, gelatin, or hyaluronic acid. And we also can scale up some the production of other type of nanoparticles, like hybrid nanoparticles, with functionalities like antimicrobial properties. Pilot 10, it's also interesting to nanotransform different biomass residues to provide fillers for final applications like foams, adhesives, and prepregs panels. And this enzymatic process can be interesting for different industrial applications. So with Pilot 9 and Pilot 10, we can provide higher amount of functionalized fillers for different applications, but also we have experience to adapt our process to different interests for the final application. We also have the facilities to characterize all these nanoparticles and fillers. So that's all. Thank you. The PI of the group, Sanko Sanov, will be here if you want to learn more about this Pilot 9 and Pilot 10.
Okay, thank you, Silvia. Okay, we are moving to the next speaker. The next speaker is Laura Bugioni for... Is it better? I have the Shitek now, no? Yes. Sorry, Andrea, you are the next. Okay. Ok, Laura.
Okay, good morning to everyone. No, she takes. No, per mandare avanti schiaccio. So, good morning to everyone. And pilot 9, number 8, is dedicated to biopolyols grafted bio nanofillers. The responsible organization is the CNR, and in particular the Institute SCITEC of CNR that is located in Milan. Short presentation of SCITEC. SCITEC carries out both basic and applied research in the field of molecular science, such as chemistry for life, advanced material, chemistry and energy, green chemistry and sustainability, and heritage science. The institute is certified by Question, that is a tool devised by Region Lombardy to promote the innovation ecosystem through cross-mapping of research and innovation center. And the main activity laboratories are equipped with instruments relevant to the process of research, especially in the field of chemistry and material science. No. Concerning the process, we have set up two functionalization of filler, one in filler in suspension, such as those provided by Melodea, that is a crystalline nanocellulose in water, and one process for the filler in particles. Concerning the functionalization of filler in suspension, there are 4 steps, mainly 4 steps: freeze drying, followed by the filler coupling, then washing by centrifugation or soft extraction, and finally drying. In particular, there is an example of what we can do with crystalline nanocellulose of Melodea. Melodea is a partner of BIOMAT project. So the suspension, nanocellulose suspension, is freeze-dried. Then this nanocellulose is dissolved in appropriate solvent. Then there is the coupling with a polyol chosen, and then purifying steps by a soxhlet extraction to remove the unreacted polyol. And in the end, there is a drying in step by oven. Concerning the functionalization of fillers in particles, such as provided by Senti, calcinated silica from rice risk. There is a step of activation, a drying step, polyol and silane reaction, a filler coupling, then washing and drying. The first step is the activation of the calcinated silica. It takes a long time, 1 week, to activate the oxygen on the silica. Then we use sodium hydroxide in water, then a drying step by rotavapor and oven for 24 hours. Then the reaction with the polyol and the silane, and then the functionalized silica is washed by centrifugation or soxhlet extraction, and then drying in the oven. The pilot performance goes from 400-gram batch to 1 kilo batch. It takes 4 weeks and 2 persons. The pilot main products are CNC grafted with 20% weight of polyol, 4 grams of crystalline nanocellulose, and regarding the silica, 25% weight of polyols. The sustainability deals with the fillers that are from renewables, and regarding the grafting on silica, the process is without solvent, is in bulk or with a little quantity of solvent. Here are some picture of our equipment, the freeze drying, example of freeze drying that works at minus 51 degree and the pressure of 0.8 millibar. One example of glass reaction reactor from 6 to 10 liters. Then the megafugue, centrifuge, and of course ATGA and FTIR for the characterization of each steps. And thank you.
Laura. The next speaker is come vuoi? Tanto. Okay, the next speaker is Andrea Miniger from AP.
So good afternoon to everybody. My name is Andrea Miniger and I represent AP Polymers. So this pilot number 11, is a little bit different from other pilots in the sense that you have seen the same company or research center with the two pilots inside. In this case, this pilot is a sort of hybrid pilot in the sense it's composed by AP and Fraunhofer. So the physical pilot you will see in the next presentation, is at Fraunhofer Institute in Germany, but the recipes are developed by AP Polymers. So a few words, sorry for this is a different format, but we will manage. Just a few words about the AP's expertise. The expertise is mainly on the organic chemistry, on petromolecules and bio-based derived oil. So basically, we synthesize, we test, we characterize, and we use also in formulation to assess the usability, new biopolymers, in this case biopolyols. Our focuses are on process scalability, so the new biopolyols have to be easy to be upscaled and produced at the industrial scale. Of course, cost and performance. Sustainability is always a plus, but especially now, and reach compliancy. We want to obtain bio-based REACH compliant polymers so that in case of successful results, it is not necessary to cope with the very long and expensive REACH registration process. We take care of the definition of a technical specification, the freedom to operate analysis, of course, in order to not overlap to existing patent, and before transferring the protocol to other partners, in this case, inside this project to Fraunhofer Institute, we optimize the standard operating procedures. We stop at TRL 5 in the sense that we don't go into commercialization of the products, but several of our biopolyols, especially derived from cashew nut shell liquid or cardinal, are commercialized, are developed on request of Cardolite Corporation, and you can find on the market. Of course, I already mentioned that we also make some internal formulation work, very preliminary, to assess the real usability of the new biopolyols inside typical polyurethane formulation. This is part of our instrumentation, only to give you the idea that we operate between TRL 3 and 5, so we stop at you can see on the top left, on the 5-liter reactor, which is enough to produce a sampling for partners in the project, but also to industrial company for the first evaluation. We have now also a pressure reactor, of course. We have also HPLC, GPC for the chemical characterization, or the universal machine for mechanical one. And the last acquired instrumentation is for the processing of thermoplastic polymers, again on the lab scale. In terms of products developed within BIOMAT, we have been developing biopolyols from plant oils, sunflower, linseed, etc., but also from lignin, using a process which is already known and published, but that we have in some way customized for this on the specific application. And the developed biopolyols are both for rigid and flexible forms. In terms of performance, first we have a compatibility with the standard raw materials for polyurethane systems. We can cover a wide range of reactivity. And there is also the possibility to design or redesign or optimize the biopolyols to give a wide range, to cover a wide range of properties of the polyols and of the resulting forms. And can be used at, I would say, high level to maximize the final bio content. In terms of sustainability, we have bio-based content up to 88%. Our replacement measured in BIOMAT is still at 40%, but with more formulation attempts, it's also possible to increase, or it's possible to blend the different polyols. So I thank you very much indeed for your attention. If you have... Thank you.
Thank you, Andrea.
I'm available.
Thanks,
Bye.
Andrea. The next speaker is Fraunhofer for the second part of the presentation on the scale up of the polyol. Okay. Thanks.
You? No? Yeah. Ah, yes. Yes. So, hello everybody. Good afternoon. Presentation. Good afternoon. Buongiorno a tutti. So, my name is Georg Werner. I'm from Polymer Pilot Plant Center in Skopje. So this is a pilot center in Skopje, is a joint initiative of Fraunhofer Institutes for Applied Polymer Research and Institute of Microstructure of Materials and Systems. ERP is for synthesis, INWS for treatment and workup. It's our contract research and synthesis and processing of polymers in pilot scale. With the annual budget of about 4 million euro and about almost 40 employees. We are in the middle of Germany, between Leipzig and Halle, and so in the middle of Europe. And with very, very long tradition, the first synthetic rubber from butadiene was produced there with sodium as a catalyst. Okay, what we can make solution polymerization, for example, producing of rubber, batch and continuous heterophase polymerization. That means latex polymerization, polycondensation, for example, polyester, polyamides, polycarbonates, in continuous line, and hydrogenation and NIDA technology. It's about producing of polyamides and rubber with flexible multi-product and multi-purpose pilot plant. So in general, polymerization, what we have, it's a wide range of volumes with different reactors between 50 up to 1,250 liter. with advanced infrastructure, which is safety with waste gas combustion, waste water treatment, with a flexible process control system, and of course with fully registered chemical pilot plants. So we can do scale up and scale down. Scale up, everybody understands what it is. Scale down is sometimes necessary tool, for example, for study of process, for understanding, and for improvement. The typical campaign operation lasts between 2 weeks and 1 month. Very important thing is that the chemistry and the recipe is fixed. Our task is to decide which lines, which equipment, configuration, stirrer, reactors, and so on, and of course the security of the concept and logistic to organize the logistic. And we work in shift operation. That means day and night. So small joke for you. That means that the scale up is not always that simple. Okay. Here, for example, this is scale down of disc reactor for polycondensation, for example, for producing of polyester. Here, scale down in a ratio 100 to 1. The left is the big reactor, and the right is the scale down reactor. Okay. And back to the real life, some remarks. The most important thing is the organization of logistic, because without logistic does not work anything. And what we can build reactors, we can rebuild, we can improve, we can construct. And one remark from the real life, the rule of pilot center number 1: be prepared for the unexpected, or be prepared for the unexpected. So, thank you very much. That's all.
Okay, the last but not least, to close the circular economy, the last presentation is in charge to Fraunhofer, and it is related to the recycling of polyurethane foams.
Yeah.
The floor is yours.
Thank you. Yeah, hello. Also from my side, my name is Lutz Hartmann. I'm a colleague of Georg. So I'm also from the Institute for Applied Polymer Research, but I'm working for a different research department, namely PICO, which stands for Polymeric Materials and Composites. Yeah, for the expertise of our institute and as well as our research division, I would like to refer to our websites. The PICO, in a nutshell, is engaged in the development of composite materials, especially fiber reinforced plastics with typically thermosets as a matrix material. And our claim is that we cover the whole value chain, starting from the monomer, where we're doing chemistry, till the manufacturing of parts or prototypes. We are investigating alternative curing methods, so microwave will play a role later on, but also we have investigated in recent projects UV or IR or electron beam initiated curing. And we also have available all characterization techniques. This means mainly mechanical characterization as well as the characterization of the fire behavior. And yeah, in recent past, and also this will play a role later on, we have put more or have paid more attention to questions of recycling and reuse. Okay, now I'm going to introduce our pilot, which differs from all the others, I think, which have been introduced so far, because we are not aiming at composing or synthesizing a material, but we consider the fact that each polymeric part, or also each polyurethane part, of course, reaches its end of life, and then the question is, can it be decomposed again, and the decomposed material, can it be reused in further the synthesis of new materials? We would like to perform this decomposition in a chemical way, so glycolysis or amanolysis are approaches, but the special point is that we would like to supply the energy which is needed to initiate the reactions by the irradiation with microwaves. And here we see the so-called Hephaestus furnace, which offers a total volume of 8 cubic meters. It possesses in total 36 magnetrons, which can be switched individually, so that we are able to tune the dose of radiation. And we are also able to operate it in a temperature-controlled way, so we have installed an IR camera as well as fiber optical sensors to measure the temperature of objects which are irradiated by microwaves. And in the BIOMAT project, our goal is to perform a microwave-assisted boiling of the polymer in a specific recycling agent under reflux conditions. We have set up this pilot so far on a small scale. So the reactors you see here have a volume of 3 liters. We see on the left the initial state where the reactor is completely filled with the foam and the recycling agent. So bringing them together leads to a certain swelling of the foam and fills up the whole reactor. Then in the middle you see an intermediate state, so decomposition has already taken place to some extent. And on the right picture, on the small scale so far, but you see that we intend also to couple more than one reactors in terms of their cooling. And the next step in the development should be that we scale up this small approach to larger volumes. So at first, the implementation of a single reactor having 30 liters is envisaged, and the combination of at least 2 reactors of 30 liters is then a further second step. Yeah, this is just on the small scale, the time dependence of the upper picture of temperature. So we see in this case it was ethanol amine, just to illustrate our work, where we were able to achieve to reach the boiling point, which is around 170 degrees Celsius. The spikes you can see we have interrupted boiling at some times to extract some samples for characterizing the progress of the reaction. This was done by using IR spectroscopy, and also we measured the viscosity during the degradation. And the green curve above, this is a temperature sensor which was installed in the reflux condenser. It indicates us that since we do not exceed temperatures of about 40 degrees Celsius, so we know that we have not to face any outlet of hot vapor of the recycling agent. And in the lower graph, we see basically the temperature evolution of the power we have to apply, which as this the relative power in terms of that, or 100% corresponds to the maximum power of all magnetrons. And so here we're operating at only around 5%, which means in absolute numbers a value of 1 to 1.5 kilowatt. So the prerequisites we are needing from potential customers is as precise as possible the knowledge of the formulation of the material we are expected to decompose, and also we should discuss which recycling agents are possible. This would enable us to optimize this process. One could ask, of course, why to use microwaves. Here the crucial point is that we generate heat only where it is needed. So we heat up by dielectric heating only the recycling agent, but all the rest of the setup remains more or less cool. So this enables us first to reach the boiling point rather fast, and then during, as I have shown on the one slide before, during the degradation we have to expect only a low energy consumption. So the output is of course the degraded polyurethane, and here are two potential continuations. First, we could reuse this decomposed foam in the formulation of new polymers without any further treatment. And the second approach could be that we purify the decomposed foam and try to separate single components from it, and after this again the reuse in new synthesis is envisaged. Yeah, and to end my presentation, I would like to briefly point out some other potential application of the microwave heating. There are some which could be called trivial, such as tempering or drying of materials. But also we are able, as it can be seen in the middle line of pictures, we are able to indirectly heat up materials. So we see in white, this is a tool made of a material which is thermally insulating. And the black, maybe I can, this black layer is a very efficient microwave absorber. And so this enables us, for instance, to reach inside this tool temperatures up to 1200 degrees Celsius. And this was used, for instance, to burn such 3D printed cups made from clay. And a second potential application, I guess it will not be of interest here, but I would like to introduce it briefly. This is just the selective heating of conductive material. So here the example is that we have printed a heating structure on an automotive armrest, and on the IR picture on the lower right, you see that by microwave irradiation, only the conductive part is heated up, whereas the underlying polymer in this case remains cool because microwave absorption does not take place there. Yeah, that's all from my side. Also, I will be available for questions later.
Perfect. With this presentation, we have concluded the presentation for the plant. Now we have a small presentation on the services that you can access with the BIOMAT project. Can you close the presentation?
I think it's saved in another folder. BIOMAT. Yeah, and the first. Okay. So, good afternoon, everybody. My name is Ilana from Bar-Ilan University from Israel. Actually, I'm representing a group of chemists, and our main expertise is chemistry and coating of surfaces. But in the current project, we are serving as a center for characterization. We are sitting in a big nano center that combine together chemistry, biology, and physics department. And we have an equipment center that all of us can use it. And it includes a well-known chemical physical characterization equipment, such as XRD, electron microscopes, XPS, AFM, and etc. I just outlined few of the equipment that might be relevant for the current project. We can perform XPS analysis that it's actually give us an indication on the chemical composition of the surface. We can do an FTIR analysis, which given a fingerprint of the polymers or any other compounds, including the functional groups that you have on the material. We can perform TGA analysis, what is actually checking the thermal stability of your composites. We can do is solid state NMR, that is actually a fingerprint of the polymer structure, and a surface morphology by using high resolution scanning electron microscopy and AFM. Some new stuff that we have developed for this project, we can monitor water remediation by checking the absorption of organic dyes and heavy metal ions. If the substrate that developed in this project can absorb any hazardous compounds in water. We can also test volatile organic compound evaporation. This special technique that we have developed, you put your substrate in a closed chamber, and this chamber is connected to GCMS, and we can actually collect very small amount of volatile organic materials that evaporate within the time. We are able also to perform antibacterial tests for any kinds of bacteria. And some new equipment that we have purchased for this project, we can perform flammability test. It's a new equipment that it's applied with different ISO standards, and as well air permeability tester that also works with different ISO standards. So this is all from my side. We will be happy to assist you with the characterization.
Thank you, Ilana. Okay, very quickly, the next speaker is, I don't remember your name, Project Hub, but Mattia. Sorry, Mattia.
So good afternoon to everyone. My name is Mattia Costamagna from Project Hub 360, a small company located near Turin. We are the provider of free services, the business plan development, the lifecycle assessment and lifecycle costing analysis, and the intellectual property management. I think that you know that the goal of a business plan is to support companies in the commercialization and exploitation phase of both final product and processes. This can be done through a qualitative and quantitative market analysis, just to evaluate the sector trend, the potential customer, the competing products, the entry barrier, and the attractiveness of the project itself. The service will include a commercial strategy and an exploitation plans to support the launch of product and process into the marketplace. The economic study is based on SWOT analysis, business model canvas, financial plans, and assessment of the market positioning. The service will also include a communication plan, a communication strategy to bring the products successfully to the final customer and stakeholders by finding characteristic needs and motivation of this audience. To sum up, the main characteristics are a detailed market analysis, an analysis of competing key players and products, an analysis of the value proposition of the innovation, the development of a commercial strategy, of financial plan, that by taking into account the entire value chain will make it possible to estimate the cost and profits, and also a communication strategy. Another service offered by Project Hub are the lifecycle assessment and lifecycle costing. These two kinds of analyses take into account the entire life cycles of product, so from the extraction of raw materials up to the final recycling or disposal, and they evaluate the first, the life cycle assessment, the environmental impacts. Instead, the life cycle costing, of course, the cost related to the life cycle of the products. So the goal of LCA is more on the environmental impact. It follows the ISO guidelines. Through the information collected by LCA, it is possible to assess the effectiveness and sustainability of product and process for market application. These are the phases of the analysis. Basically, it is necessary to collect all the information related to the products called input and output data, and then translate this input-output into environmental impact, and the interpretation of this impact will make it possible to successfully improve and develop more sustainable product or process. There are several impact categories, not only global warming, that is the one more known nowadays. And basically another point is that life cycle assessment allows to develop in the future more sustainable products. A similar approach can be applied to evaluate the cost of a product or process along its life cycle. This is very important because usually the initial cost is only a small part of the total cost. And LCC is a tool that allows, first of all, to increase the efficiency. It supports corporate decision-making processes. It allows to save money, to save time, thanks to increase the efficiency. Of course, allows to assess the economic sustainability of the product along the entire life cycle, and it can be make link within the environmental analysis and the business case development. Both the analyses are based on primary data. LCA allows to obtain a reliable environmental impact. Both the analyses assess the entire value chain, allows the identification of hotspot, both under the environmental point of view and the economic point of view, and make it possible to compare your products, your process with benchmark product or process already present in the market. The last service provided by Project Hub is the intellectual property management. This is done through analysis of patent through specific database, an analysis of the innovation case study, an analysis of the identification of claim towards IP protection, analysis of technology transfer and exploitation plan, and also the assessment of the risk related to the exploitation of the result to products. This was a brief overview of the service offered by Project Hub, and if you have any questions, you can contact us. Thank you.
Thank you, Mattia. The next speaker is Global Wise.
As the last speaker, I have the challenging mission of compressing my speech into a few minutes while keeping you awake. Our service is mentoring for fundraising, explaining what it is and what it includes. Fundraising can be mainly for startups, but also for SMEs, require special project, new market, new product launch. We will try to be generic, talking about the issue itself. The goals of fundraising, of course, it's first guarantee business stability and growth to fuel the business run, reduce financial risks. Often an investor, either strategic investor with familiarity with the market, so we add strategic partners. It's an added value of fundraising. In this specific project, we encourage SMEs to participate in the open tender and accelerate development of nano-based polyurethane and other material. Fundraising has several stages. It starts with the pitch deck, or what we call have different types of pitch. This is the toolbox of the fundraising, the one requiring funding. Without this, it would be very hard to get any money, and we will elaborate on this in a minute. The next stage is mapping the financial market, finding where can we get the money, from which entities, what kind of money, a few words about it in a minute. And then we find the opportunities, we study them, contact them either directly or indirectly through so-called finders. You not always contact the investor itself, and then hit the road. We'll talk about the pitch deck first. As I said, this is the most important part. Actually, a pitch deck is a presentation to the investor, and it has various types. It starts with what we call an elevator pitch. You enter the elevator, and Bill Gates is in the elevator, and you have a few floors to convince him that he will invest in your company. Sure, you're lucky if there are more floors, but normally the building is not high enough, and you have a few minutes to convince. This is normally to attract attention. If he is interested, he will then ask another meeting with the expert, and then you go to the full deck. So first thing is we have to explain what is the problem we are solving, what is the need, what is the market need. You have to convince that you are coming with a solution to something that is really needed. I often see startup companies with a beautiful idea, solution, but then we are looking for the problem. I mean, what are you solving now? Then we outline the solution, of course, not in too many details, because normally in the first meeting or first impression, you're not going into the technical details. This comes later on. Then, of course, presenting the company and the company vision, which is very important. I personally see many startups, many SMEs, and the first thing when I see lack of vision, I ask them, what do you want to be in a few years' time? What is the impact you want to leave? What is the character? What kind of market? If they don't have a clear answer of this, it's just like asking a boy, a young child, what would you like to be when you grow up? And if he doesn't know, he's not ready for investment. And then you have to understand your market. Again, it's a very important criteria. Starting companies, small and starting young companies that are not familiar with their market have little chance to succeed. You have to know your market, to know the competition, to know the behavior, the trends, the mentality of the market. And before you go to sketch the next step, understand your market. Only then you can draw your go-to-market strategy. Go-to-market strategy meaning, what is the business model? How do you get your money? Where from? Which are the preferred customers? What are the stages? These are the principles, the strategy of the company. When we translate this strategy into figures, we have a business plan. We know where to invest, in what time, how to invest, what do we expect as revenues, when is the break even, etc. A business plan can be very detailed, and it's important that it will be very clear. Once we have this, we have to make our plan, how to continue. We make a roadmap. A roadmap has milestones, be it technical, financial, marketing. You have to sketch the road you are approaching. And then the equity plan, we will show it in a minute. Okay, you want an investor to give you money. You have to show him how much money and what did he get for it. What is it if it's an investor? So we need to give a clear picture on this, and then we can do the fundraising plan. A business plan can be sometimes a thick book, but the bottom line is a P&L forecast, a profit and loss expectation. In this example, you can see 5 years with a revenue on behind each figure here. We have a whole description. We understand where do we get it, how do we get it, what is the revenue stream, is it products, services, which market? Of course, we have the details. And then we have the cost of service, or the direct costs that are linked to sales. A gross profit, I'm not getting into details now because, as we know, the time lunch is waiting, and I cannot. It's very interesting. I could talk hours about it, but you will then kill me after a minute. So, and then we have the fixed costs, building, administration, etc., and we have our EBITDA, earnings before interest, depreciation, tax, and amortization. These are kind of this is actually the real profit of the company, and then before financial costs and the net profit. So you can see here a break even at the end of the third year. It's just an example, of course. So we know we can show that a company after 2.5 or 3 years investment will turn into a profit. We have to convince that we know what we talk about. Below we have some lines for control. We always see that the revenue per employee must make sense. There are some rules for it. The percentage of profit and revenue makes sense, but we will not discuss this now. Now, as we know, the next thing is to sketch the cash flow. Net profit is not cash flow. We have some depreciation, delays, canceled orders, etc., etc. We know how much money we expect at any time. We have some, let's say, managed to raise some grants or some money, or I would say owners' money, and we see our cash flow. So if, for example, in the first year we would run, I would say, a loss or investment of almost 2.5 million, we need 2.5 million. The year after, we need another 3 million, etc. So we know how much money we need. Of course, as I said, this is superficial. This is just showing you the figures. It must be well thought. And then there is a line of the company value. Now, company valuation, or if it's just an activity, it's a whole theory. There are many ways to calculate company valuation, but at the end of the day, company valuation is just like a value of a house. It's the price that the market is willing to pay. I mean, if the investor invests in a company, he wants to get some percentage, you need to tell him how much he will get. You must know what the company value is. So having this, we can build up our equity plan. Every investor, let's say if the company value, what we call after money, after investment of 2.5 million, then the investor will have 41.6% of the company. This is, he will dilute the founders who had 100% before to 58 1/3. The next investment will dilute the others, etc. And I'm talking only about diluting. There is another investment, non-diluting, grants, all kind of different investment that are money available without taking share in a company. When we have all this, we can summarize the steps: the pitch deck, market mapping, study of the opportunities, connect, and hit the road. We would start with available money. Before we get partners with the company, we would like to see if there's available money, like Horizon is just one example. Looking at national funds, multinational funds, variable corporate, various corporate impact activities that are available in the market. I mentioned Bill Gates before. It's just an example. Some go to the public to crowdfunding. This is already diluting. The crowd is becoming in one model, they are becoming partners. In other model, they get some products. Depends. If a company comes up with a new suitcase type, you can offer every investor of $100 a suitcase with a worth $500. In that case, the crowd is not taking percentage of the company. All kind of environmental organizations, Greenpeace and others that have available money to important development. Incubators and accelerators that are dealing mainly with startups, but they are taking some shares. Angels and angel clubs are private people that are looking to invest. Some people buy real estate. Some people would rather go to invest in high tech and environment, and there are many of them. And venture capital companies and organizations that are looking to invest money. There are many of them. As I said, you must map the market and understand where to go to, not just to go everywhere, not to waste your efforts. This is in a nutshell. I can't hear you. Oh, go back. Well, that's just a moment. Where do you like? This one. I cannot make the screen smile, but you can make a picture.
Perfect. The last presentation, 5 minutes, no more. It's not correct.
But I have
Outside.
it.
Oh. Ah, okay.
Good evening. My name is Oscar Brandon, and I will present you the digital twin platform on behalf of ITG. We are a research and development center located in the northwest of Spain. So the digital twin will be a web-based application that will be installed in the 12 pilot lines that were presented before. And first, I will tell you about what this tool provides and then how. The BIOMAT DTP will provide monitoring, modeling, optimizing, what-if analysis for the development of the products within these BIOMAT testbed lines, and also a product recommender. So the traditional product or the available products on the market will be matched with the ones produced in BIOMAT. The BIOMAT DTP consists of 3 modules. The first one deals with data acquisition and traceability. So we collect all the data to the platform, and we also provide traceability, for example, for batch production. So we have identified all the data that belongs to a certain batch. Then we have the toolbox, the DTP toolbox, that allows to view all the data available for a certain pilot. Also a simulation manager, since the BIOMAT DTP platform will have models that model, so to speak, the production, the process data, and also the spectral data. This toolbox also has a production dashboard to oversee the KPIs, critical process parameters, etc., and what I mentioned before, the spectral data. And finally, the products recommender, a catalog of the BIOMAT products with all their key parameters and the product recommender. So the platform proposes the BIOMAT substitutes to commercial products depending on their key parameters. So that's all.
Thank you very much.
Thank you so much for your attention.
Okay, now we move to the lunch in the other part of the research area. Roberta? Okay. Yes, please.
Technology transfer that the project offers due to the money from the European Commission, and the earlier you come, the better, because we cannot do more than 5 to 8. And then if you decide to come, we will instruct you about the administrative forms which we have to do for the European Commission. And I hope to see you in the future. Just let us know through the correspondence with you. We have all your emails. You will receive all the presentations. You will decide, and you come back to us. You will have to which email to write your answer. Also, I want to thank very much to the organizers that did the girls of CNR that made an excellent job. Scientifically and socially, everything was excellent.
Thank you, Pnina, and thanks to all the CNR group, women group, and one man.
Power to
Pepe. Thank you,
Now
thank you both.
we can go for lunch. Bon appetit.